Here we go. It is time for an old-fashioned 3D printer fix-up. Hello everyone, Chris here. 3D printer fix-ups used to be pretty common on the channel. We don't take in near as many 3D printers as we used to, and a lot of the ones we get don't have issues right out of the box like we used to see. Today we have a Kingroon KLP1. This is one of the original KLP1s, and there's different models. Kingroon did send one over that's much newer and a lot different than this one, and it does work a lot better. But any 3D printer I have that has an issue, I feel compelled to fix it. Now on this model, the mainboard was always the issue. One way or another, it would always fail, and I have tried multiple versions of the stock board to try to get it to work with no success. So I thought it would be a great opportunity to swap out the mainboard on this machine with one from BTT. We will be using a Manta board. We'll be running Clipper, but also it's a great way to show you all the steps to swap out a mainboard, get Clipper configured, all set up, and then we'll move to things like CAN bus and how you can make that work on your mainboard and your printer. So this is going to be multiple videos. Hopefully you hit subscribe, hit that bell for notification, as the new ones do come out every week, and there'll be a lot of great information in this series. So let's just jump in, we'll get started. Let's take a look at the BTT Manta board that we're going to swap out into this machine. So let's start with a bit of a recap. This is the Cheetah board that came in the Kingroon KLP1. It does have the eMMC drive on it right there. I had a lot of problems with multiple things. I was having problems with these drives being consistent, and then when I would reboot, the board just wouldn't come back. But this is designed to have a Raspberry Pi-like environment over here, or a Linux side, and the MCU side, so that you can use both same board. I just couldn't get it to be consistent. A couple of reboots, it would just never come back. And again, I tried 3 different ones of these to try to get it to work. No go. But notice it does only have 3 drivers on it. You're going to see that during the install, because this was designed to use CAN bus for all the extruder stuff. So we'll take a look at all of that. And here is the BTT Manta M4P board, the new hotness we're going to be using for this build. You do get a BTT sticker. Thank you, BTT, for the support on this project. And of course, you do get a duck. So like the old days, let's just go around the board. I'll show you what all the things are about here. We're going to hit the highlights. There's a lot of things this board can do. It's very capable. But right out of the gate, those that are following along at home, notice that this board does not support CAN bus right out of the box. The 8 version, the M8P does. This one does not. But we're going to get tricky with this. We'll do all of that in later videos. But let's just start up here. Here's all your motor drivers and the plugs for them. You have E, X, Y, and Z. And then you have the jumpers for those drivers. These up here, that's what will allow you to use sensorless homing. We are going to use it on X and Y. We'll plug in our caps. We'll do that here in a minute. But then you have the motor voltage select down here. In this position, this is going to allow you to use input voltage of the board. If you flip it over to these 2 pins, that will let you use its own input voltage up to 56 volts, I think. But the power plug down here does say 48 volts. But if you're in that configuration, that's how you switch it. The jumpers down here, this allows you to select which mode you're going to use the driver in. We are going to be using TMC 2226s today. They're a lot like the 2209, but we're going to use them in UART mode, and that's this jumper set right here, these pins. Check out the user guide if you'd like to use things in standalone, but by default, this board came in UART mode. So that's where the jumper should be. Next up below that, these are all end-stop pins. Remember, you can mix anything up you want in your configuration and use these pins for whatever you like, but this is E, X, Y, and Z end-stop if that's how you'd like to use them. You could use E for something like a filament sensor if you wanted to. You can always mix it up. And then you do have some step pins down here exposed, so you can use this with different kinds of drivers or different kinds of boards. It just gives you access to those pins. You see that a lot on boards. You also have some access down here to some of the different driver pins. Then over here, you do have 3 fans that you can control with G-code. PWM, fan 0, 1, 2A, and 2B. A and B, you can control them, but only as one. So think of it, two fans, same control. It just gives you the option to use two fans in tandem, but not separately controlled. You do have blade fuses on this board, which is always nice to see because you can swap them if you ever needed to. But over here you have 24 volt for input and 48. Remember I said for that motor drive if you need to switch to a higher voltage. And then over here there is one for the heat bed. These are 10 amp. That one should be a 20 amp fuse. Then you have your power inputs. One all the way over here. This is for the motor control. And then you have your standard input, 12 or 24, 24 pretty much standard nowadays. Your heat bed, this is the output for it, and then your extruder, or hot end, so your heater. We're not going to be using that, remember, because we do have a tool board, but that's where the stock location is. On this side, we're getting into the Linux side of the house. We'll just run down this real quick and we'll hit some of these in a moment. But you have Ethernet for your network connection for your cable, a couple of USB ports to communicate with Linux, USB-C over here, you can talk to Linux, but also you can power the board up. You'll see that when we flash firmware, HDMI, and then you also have an SoC. They try to use SoC to reflect the single board computer over here, the compute module, but this is SPI 0. You also do have EXP1 and 2. If you would like to use the old school rep wrap screen, you can configure that here and use those if that's something you want to do. Dip switch is here. That controls the different compute module that you would like to use. It sets a couple of different things. We won't need it with the Big Tree Tech module we're going to use today, but if you wanted to use an actual Raspberry Pi CM4, you'd have to change up these switches a bit. That's all in the manual. And then let's jump back over here. We have our extruder thermistor for the stock heater location, your bed thermistor, and then you have a fan port over here that you can use as a fan for your computer. Now, this is an always on fan. You could use a smaller type fan. If you wanted to cool this off, you could use it for drivers, but it will always be on. It's not controllable. And then you have a port here for your BL Touch. That would be for the servo mechanism like the BL Touch would use and the trigger pins like an end stop. Back through here, we do have our port for our computer. Again, we'll see that in a moment. Another USB port. You do have DSI, CSI over here. Some of this you can only use with that actual Raspberry Pi module. I'm not sure about the CB1, CB2. They are a little bit different. We can check that out later, but these are for things like screens. Here you have some RGB ports you can use for lights. You do have some more RGB up here, and then you have the GPIO like you would on a regular Raspberry Pi computer, the 40-pin header. They'll work the same. Once again, up here you do have UART2, SWD, and SPI1. A lot of this we're not even going to use. It's for a little bit more advanced programming concerning the board, but it is all in the user manual. But that's just really quick, a high-level rundown of what we have. If you flip it over, we do have SD card slots. Big Tree Tech always does a really good job at badging. But SD cards over here, this is the one that's going to run your OS for Linux. And this one, it's a full-size SD card. You can use this to flash your firmware. This board does also support flashing internally. You can do it command line, but only if you have it set up to do so. It can be a little tricky to use that. This card's just as easy to do, but if that's something you want to look at, we can configure it for sure. So now we need a compute module. This is the Big Tree Tech version. This is the CB2, the newest one. And you can see the back of the board. It's pretty self-explanatory how it goes on. You have these pin connectors, but just pay attention to the mounting holes. You don't really have to use those in most cases, but it's going to be over to one side further than the other, so it kind of gives you an idea of how to mount it. But it'll just go right on here. Make sure it's lined up with all those holes. That's how you can kind of tell that the connectors are lined up correctly. And just push with even pressure on both sides until you feel it snap in. So now we have a compute module that has memory, a processor, all that good stuff to run Linux, so we can run Clipper. It does come with a Wi-Fi antenna and a port. I do suggest that you use this, especially since this is going to be in a metal case. We can use the tape on the back of it to put it someplace so we can get good Wi-Fi coverage. It'll just press onto this port right here. Then back over to this side, remember we really only need 3 drivers. We're going to be using the BTT 2226. Again, pretty self-explanatory. It's got some extra pins for diag and talking to the driver, but we just need X, Y, and Z. So we'll start here, but mount your drivers. We've already got that jumper set to use UART. They'll go right on there like that. And we'll do all 3. Make sure you do use a heatsink. They do get rather warm. And then on X and Y, we're going to use sensorless homing. And they do give you a lot of connectors in the box for the board, including the jumpers you need. They're super small, the ones that you need to trigger that sensorless homing or stall guard. So we'll just put a jumper cap on for X right there, and then one for Y. Make sure you get it on correctly. It is kind of easy to mess those up because they're so small. But the hardware is pretty much ready to go. Now we have to work on the OS. I will leave a link in the description, all the info you need on this board. But do pay attention if you're using that Raspberry Pi CM4 rather than a Big Tree Tech one. There are some different rules that you have to follow. The Big Tree Tech one, as you would expect, is a little bit more straightforward. Now, we have to talk about Armbian and the Linux OS versions that Big Tree Tech give you. So if you have the Raspberry Pi module, of course, Raspberry Pi OS is supported. It is open source. You can get it from pretty much anywhere. CB1, it is supported directly by the Armbian project, which is open source. So you don't have to get the OS from Big Tree Tech. That's when you get in trouble. If you're dependent on the company, what if they go out of business? What if they decide to not offer the files anymore? You're kind of stuck. CB1 is covered, but today we are using CB2. It is in the works. Folks at the Armbian project, again, open source, so it's just people in the community, but they are working on CB2, but it's not out there yet. We are going to use the version from Big Tree Tech today, but just keep that in mind. Most of the time, a couple of months after these have been out, the folks working on the Armbian project have already created an OS that will work for it. But on to the Big Tree Tech GitHub page, where we do a lot of our video work, it seems like. But we'll head in, we'll go to repositories, and notice if you search CB1. It used to just lump CB1, Big Tree Tech Pi, all of that into one repo, but now if we do CB2, it has its own. So we're using the newest one, CB2, that's where we want to go. Now in here, it's just going to be user manuals. They don't store those really large images out here necessarily. Those are going to be in the releases, but you can scroll down to the bottom to get that OS image, or you can just go over here to releases like we've done in a lot of other videos and get the one you need. Now there is a beta out here at the making of this video. They probably fixed a bunch of stuff. If you want to try it, that's fine. I'm going to hedge my bet and just get the 105, the stable one. And you can install it with minimal. If you'd like to use something like Kaya to install Clipper, we'll go over that. Or you can get the one that already has Clipper in it. For this video today, I'm going to do the fast version and get the one with Clipper. So just click this file, it'll start to download. Keep in mind, it is 1.26 gig, so it's kind of large. But we'll download that. Once that download is complete, it's going to be a compressed file, but no worries, we're going to use the Raspberry Pi Imager tool. It will read that compressed file and put it on your SD card. You don't have to unpack it. But we're going to choose device. In the newest version, they do want you to choose a device. Doesn't really matter for this which one you choose, but I am going to use the Pi 3 because this processor, that's the closest one. This should work no matter which one you choose, but we'll go there and then choose OS. We're going to go all the way down to the bottom and use custom. And we're going to select that file that we just downloaded. You can see it's got the XZ on the end. That's mean it's compressed, but we'll just grab this as an image file and we'll hit open and then choose your storage. Any micro SD card would work. Just make sure that it's 4 gig or larger so you have enough space. I've just got a generic 32 gig card, So we'll write to that one. And then if you hit next, it's going to ask you if you'd like to apply the custom OS options. That's not going to matter with Armbian or this Bigtree Tech image. It's not going to apply those. So we're just going to say no. And we're going to use the configuration file after it's been flashed to set everything up. You'll see that in a moment. So we'll hit no, and it's going to say, hey, I'm going to wipe out everything on the card. Are you ready to do that? And we'll hit yes, and we'll let it go ahead and write it. The writing can take just a little bit, but we'll let it go ahead and do that. When the write's complete, you're going to get this successful message. We'll hit continue. It does eject the card by default after the write's complete, so you might have to pull the card out and put it back in so that we can do some changes to the configuration file. So we'll do that, and then we'll open up File Explorer. We'll find our card. You will have two different ones. We want the one that says boot, because that's the side that can talk to Windows. And we want to edit system.cfg. I recommend you use something like Notepad++, so we'll right-click and edit with Notepad++. You use Notepad++ rather than Notepad because it's much better at formatting these files so you don't make a mistake. Now, if you're using the more advanced versions of the board, you're probably going to set them in here. You can see the HDMI, all the different types of screen, also host name. This is something I recommend you do. I'm just going to take the comment off of this line. I will know this device as BTT-CB2. You can change it, but for the first boot up, I would just use the defaults. You'll see why I'm going to do this here in a moment. But the most important thing is we want to set up our Wi-Fi. So we don't have to get out that Ethernet cable if we don't want to. So we enter our Wi-Fi name, BC Wireless. Remember, they are case sensitive. And then enter your Wi-Fi password. Once you are done with that, make sure they're correct, double, triple check. We don't have any of these other options right now, so we're good. We will save the file. Now you can eject that SD card and we'll head over to our Manta board. Here's our SD card ready to go. Remember, the OS card is just going to go in this slot right here. We'll use this card to flash the MCU. You'll see that here in a moment. But now you can go ahead and boot up the board because we do have a few things that we want to look at, a few things we need to configure, and you're going to have to get in SSH. Now, with that card configured like we just did, your control module here will be able to talk to Wi-Fi. So we can get to it from the computer. But to power it up for now, you can just use your USB-C port. The computer has enough juice to power this up so that we can talk to it. The power over here, when we install it in the printer, that will power it up going forward. But just for now, on the bench, we'll use our USB-C coming from the computer. We'll plug in, so we'll go ahead and plug it into the computer and power up. You're going to get a light over here for the MCU side, and then you're going to have a green light over here to show you what this compute module is doing. It's flashing, that's a good sign. Now we'll go back to the computer and see if we can communicate with it. Now, I showed you in that config file how that you could set the host name. There's a reason why I did that, because if your network likes it, if it's being good to you today, you can use that name to connect to the device. So we did BTT CB2, and if you do .local, it should allow you to go ahead and go to the board. By default, if you use that Clipper version, it already has everything installed for you. Now, the configuration file isn't set because it doesn't know what printer you're going to use this on. That's why it's throwing this error. But you've already got half the battle done. Clipper is installed, as well as Mainsail and Moonraker, everything that it takes to get this to work. Now, because we don't know exactly what's been flashed, what version is on our MCU on the board, the non-Linux side of the board, we need to compile one and then flash it over there. And to do that, you have to get in SSH. There's lots of different ways to use SSH, different tools. I always use Putty. It's the simplest. I've been using it for probably 20 years or more, so that's the tool that I use. So let's open up Putty. Here is the Putty tool. You can use that same .local address to log in, btt-cb2.local. You can save it if you'd like, but we'll just hit open. And we'll accept our key. If you're using the Bigtree Tech version of the OS, our Linux OS, your username is going to be BQ, B-I-Q-U, and your password will be the same, B-I-Q-U. You'll get the splash screen when you log in. I'm going to go ahead and make this text bigger so you can see a little bit better on the video. So here in the home directory, we're just going to do an ls to see what's in there. This is where the whole install has been done, but you can see we do have a Klipper folder. So we'll just cd into Klipper. That's change directory. You do an ls and take a look in there. These are all your configuration files, but this is where you can do the compile to make that file that will go on the MCU. It's going to be called clipper.bin, but it's a bin file we're going to load up. So the first thing we need to do is make menu config. Menu config, all one word. Should be a space in there. That's going to pull up this window, and we have to set up the options specific for this board. Use the space bar to toggle these, but we want to enable extra low configuration. We'll just hit space. We want to change up our microcontroller architecture. This is an STM32 right there. And the model, we need to change that up. A lot of them are this F103. The Manta board uses the G0B1. So we'll hit space on that one. We can leave bootloader offset at 8K as well as clock reference. Everything else should stay default. So we're good here. We can hit Q to quit, and we do want to save the configuration. So just hit Y. And then from here, we can just do a make, and that's going to compile it and make our file. It takes a couple of seconds. It's going to roll through the log. The compile is complete. You can see it created our files, our clipper.bin, in out. If you do another ls, you'll notice there's an out directory. Let's just do ls out. You have to spell it right. We have a clipper.bin, but we need to get that over to our SD card to load it on the board. There is an option on this board. It's not the same with every board. You can use the DFU. That's an internal interface that you could use to flash this, but it's kind of particular on how it wants things done. But it's easy enough to get this file over to an SD card so that we can load it. My favorite method is to just copy it to the directory where the system files are. So you can use your file explorer here for your machine. In your dashboard, if you go to machine, all these configuration files, we can just copy it to config and then use this interface to download it to our computer. So let's go back to PuTTY, and we're just going to copy CP from the out directory. Remember your /, it is Linux. We'll do Klipper, use tab to auto-complete things, and then .bin. And we want to copy that to our configuration directory. All of that is stored in printer_data back in the actual home directory. So we need to step back a little bit. I'll walk you through it so you can understand what we're doing here. But if you do the tilde, that's up there by the 1 key, if you're not used to using that, that's the home location. So tilde / printer_data, and then / config. That's the file or the directory where all these files are located. You can see back here in mainsail. And then we'll just do /, we want it to be called clipper.bin. We actually want it to be called firmware.bin, but I'll show you that part here in a second. But that's going to get it over there so that we can see it through the web UI. We'll hit enter. It's copied over here. Again, I'll show you that in a second. There it is. You can see it popped up. But just so you can understand what we just did, I'm going to do cd with 2 dots to back up a directory. Sorry, space, 2 dots. And then do ls. You can see there's printer.data. We're currently in our home directory. That's what that $sign actually means. But we're in our home directory. There's printer.data. If we were to cd into printer_data, I think I just said ._data, you can do an ls there. There's config, cd, config, do an ls, that's where all of those files are kept. So this back here is just showing this directory, if you were to ever want to update something via command line. But this, since we got our file over to the UI where we can see it, we're pretty much done with command line for now. From here, I'm just going to use a micro SD card in this converter, because remember, it's a full-size SD card, the card you use to talk to the MCU on the board rather than Linux. So I'm just going to use this and mount it on the computer. And then from the main sales screen, you've got your clipper.bin. We're just going to right-click, hit download. It might bark. If you want to keep that, we do want to keep it. We'll just hit keep. And that's in your downloads folder. So we'll go to File Explorer, Downloads. There's our clipper.bin. We'll right-click and copy that. And then we'll head to that SD card. Mine is empty. Remember, if you're having issues, make sure this is formatted FAT32. If this card, if it doesn't like the board, try a different card, a different size. That seems to be a common problem. But for now, we'll just right-click and paste it in there. And we've got our clipper.bin, but the board won't recognize it unless it's called firmware.bin. So we'll just click it once and change it to firmware.bin. Now, if you can't see the .bin, the file extension, you can change that up. If you go to the three dots up here, this is Windows 11. You can go to Options and then go over to View. And it is an option down here to either hide the extensions for known file types, but you can switch that up in here if you can't see that for some reason. But you should be good by default, so we'll just cancel that. Now we can take that SD card over to our board. So we're still powered on. Remember, we've got that full-size SD card slot. So we'll use our converter, but we'll just flip it over. We'll put our SD card in. And then you don't even have to power down and power back up. It's over here by the Wi-Fi antenna. In fact, it can kind of overlap it. But if you just hit this button here with something small, that's going to flash it. You can see a green light here. When that green light's flashing, more than likely that's pulling in something from the SD card. So it just flashed that MCU. And if you take that SD card back out, it only takes a second to do that, and take it back to the computer. We'll look at the SD card again. You can see it's capitalized firmware and there's no extension. It's actually trying to call it a cursor type because it's got a .cur on the end for current. So that's how you know it flashed if you went from bin to current. And that's why I was telling you about over here, if you go to Options and View, hide extensions for unknown file types, or for known file types, you can take that off, and then you can see that .cur. So that's the best indication you have that your MCU flashed correctly. So you're good to go. So for now, we have our current version from Big Tree Tech of Clipper and Mainsail. It's up to date. You can see there are updates down here. Be careful when you're updating things. That can screw a lot of things up. But we also have a Clipper version on the MCU that's compatible with this because we compiled it from this version. So if you're building this like I'm showing you here, I just recommend you don't update anything. You start building your configuration from here. But that's a lot more work because we're swapping out a board on this printer, so that will be in another video. For now, we're just going to go up to the power button and we're going to do a shutdown. Let's go down to the bottom and we'll shut our install down safely so we don't corrupt it. And we'll unplug the power from our board because we need to mount it in our printer. Now, if you remember, if you watched the basics videos, we made a mount in one of those videos, a custom mount, so that it will mount inside our printer, but we can also mount the board. It's just got some M3 nuts encapsulated on the back, and we can just mount our board. So the whole thing will sit on there right like this. So we'll just use some M3 screws to put that down, and then we'll go to the printer. So back to our printer, our new board and mount, it's just going to fit in just like this. Now we won't have access to the USB ports and things out the back like we did with the stock board, but for what we're doing here, especially since we have Wi-Fi, it's not going to matter a whole lot, but it'll just slide on these standoffs, and then we can use some more M3 screws to put it in place. Make sure it doesn't come off. Now for wiring, this is pretty simplified. There's not much here because we do have the CAN bus toolboard. That does simplify things, but then we have to deal with CAN. And again, that's a whole other video. But we can just get things set up that we know where they're at. So power is easy. Really the only one that I see that's going to be a challenge is the Z motor. It's not quite long enough, but I'm just going to make up another custom cable to do that. So let's go ahead and get some things plugged in. We'll start with power. That's his second set of terminals here. Let's open those up. The bottom one here, at least in this view, is the positive. Remember, if you don't have ferrules on your wires, this is a great opportunity to go ahead and put them on. And then the one above that is the negative. Then right next to that, we have our heat bed. This really shouldn't matter, positive, negative, unless you have an LED. But since it's a DC powered bed, positive is listed to go in this one here. And then negative right next to that. And then remember, this one is for the heater on the hot end. That's on the CAN board. From here, let's go ahead and plug in our heated bed thermistor. It'll go right there. Then we can do some of our motors. This one is labeled A, B, and Z. A traditionally goes in X on most Core XY configurations, so it'll go over here. And then same for B, they go in Y, so it'll go in this slot right here. We do have a filament sensor wire. We're going to plug this down here in the E0 stop. We'll configure that in Clipper. That goes right there. And then the Z wire, we did have to add a little bit longer one to reach. It goes up here. So that is pretty much everything native, what we're going to say, that's not on CAN that goes in here. So we've got a good start. At least we could power the board up and continue to configure it while we work on our CAN. So there we go. What I'm going to call the easy part is now done. At least we know more about the board. We got it installed. We got all the wires connected that we could, and we got a rough Linux install on it. We're ready to go ahead and configure Clipper. But we have a lot more to do. And there's going to be a lot of different things that we go into in this series. So hopefully it provides you a lot of knowledge over the whole printer ecosystem. Things like installing a board, doing firmware, working with CAN bus and Core XY, all that good stuff, but that will be on future videos. So hopefully you found this helpful. That's it for today, and I'll see you really soon on the next one.